In this video, we're going to find some derivatives using basic differentiation techniques. Here we're asked to find the derivative of f of x equals negative 18. This is a constant function. Remember, to find the derivative means to find the slope or the slope formula. A constant function, no matter the constant, has a slope of 0 across its domain. So the derivative of any constant function is 0. And this is called the constant rule for derivatives. In this example, we're asked to find the derivative of f of x equals 3x minus 4, which is just a linear polynomial. To find the derivative of a function with multiple terms, we can differentiate term by term. And that's what this means. To find the derivative, we can take the derivative of the first term, 3x, and the derivative of the second term, 4. To differentiate an algebraic term like 3x, we use what's called the power rule. The power rule says that we can multiply the exponent of the variable that we're differentiating with respect to by the coefficient, and then decrease the exponent of the variable by 1 unit. So to find the derivative with respect to x of 3x, we multiply 1 times 3, and then that would leave us with x to the 0 power because we reduce our exponent by 1. So the derivative of 3x is 3x to the 0 power. And to differentiate our second term is just a constant. We already know how to differentiate constants. The derivative of a constant is always 0. So now we have 3x to the 0 power minus 0. Now let's simplify by restating x to the 0 as just 1. So really that 3x to the 0, because any number raised to the 0 power is 1, is really just 3 times 1, which is 3, and 3 minus 0 is 3. So the derivative of 3x minus 4 is 3. And this makes a lot of sense if we think about it. We're trying to find the slope of the function 3x minus 4. 3x minus 4 is a linear function that has a slope that is unchanging. That slope is always the same no matter where we try to identify the slope along that line. It will always be 3. So the slope of any linear function will always be the coefficient of the x term because the coefficient of the x term is the slope of the line. So finding the slope or finding the derivative of any linear function is really easy. It will always be equal to the slope of the line. Let's look at this example. Again, we need to find the derivative of f of x equals 10x to the 4th minus 32x plus e squared. This is an algebraic expression with multiple terms, so let's differentiate term by term. So f prime of x will be equal to the derivative with respect to x of 10x to the 4th minus the derivative with respect to x of 32x plus the derivative with respect to x of e squared. To differentiate 10x to the 4th, we'll use the power rule. So multiply the exponent by the coefficient to get 40, and then reduce the exponent by 1 unit, x to the 3rd. So the derivative of 10x to the 4th is 40x to the 3rd. Now let's differentiate the second term the same way. When we differentiate 32x, the derivative is 32. And when we differentiate the last term, e squared is just a constant because e is a number about 2.7. So when we differentiate a constant, we get 0. So the derivative of f of x is f prime of x equals 40x cubed minus 32. Now again, I don't think we can overstate the importance of what this represents. If we choose any x value from the domain of the original function and plug it into the derivative, 40x cubed minus 32, that derivative function will give us the slope of the original curve at that specific x value. So this 40x cubed minus 32 is the derivative of our original function, but it is also the slope function because it will give us the slope for any given x value of our original function. Here again, we're asked to find the derivative. This time, the function is f of t equals t squared over 2 plus 1. Again, let's differentiate term by term. Because our independent variable this time is a t, we'll be differentiating each term with respect to t. And before we begin differentiating the first term, t squared over 2, it'll help us to realize that t squared over 2 is the same thing as 1/2 t squared. Now we can use the power rule to differentiate that first term. Start by multiplying the exponent of 2 times the coefficient of 1/2, and then reduce the exponent of t by 1. That gives us t. So the derivative with respect to t of 1/2 t squared is just t. Now let's differentiate the constant 1. If we differentiate a constant, we get 0. So our final derivative is t plus 0, or just t. This example looks a little different. Here we're asked to find the derivative of f of t equals 6 times the square root of t. But we haven't talked about how to differentiate roots. The good news is that any root can be rewritten in exponential form. So let's write 6 times the square root of t in exponential form. We know that the square root of t is the same thing as t raised to the 1/2. And now we have an exponential expression, and we can use the power rule again to find the derivative. Multiply the exponent of 1/2 by the coefficient of 6, and we get 3. Now we have to lower the exponent of our variable by 1 unit. 1/2 minus 1 gives us t to the minus 1/2. So f prime of t equals 3t raised to the negative 1/2 power. Now in calculus, negative exponents are fine. But if you choose to rewrite this using a positive exponent, you can. Or if you choose to rewrite this using square roots, you can. All of those forms of the answer are acceptable. If we choose to rewrite the expression in exponential form using only positive exponents, we'll get 3 over t to the 1/2. Or if we choose to rewrite the t to the 1/2 in radical form, we'll get 3 over the square root of t. Again, all of these are acceptable forms of the derivative.